Hello everyone. So let's start solving today's Leetcode daily challenge question. So the question is special array 2. An array is considered special if every pair of its adjacent elements contains two numbers with different parity. Okay. And we are given with an array of integers and 2D matrix where for queries of I is equal to from to 2. Okay. Your task is to check that subarray is special or not. Okay. So if we see this example, what is given in the question, it will be special subarray, okay, if it uh, if it if it contains what two numbers with different parity, two adjacent. Okay, we have to check with every pair. Okay, every pair means let's say 3 4. Here it is given 0 to 4. So 0 1 2 3 4. So all the element, this is considered as one subarray. So in this array, two pair can be 3 and 4. So we have to check this two are with different parity. Different parity means let's say this is even, okay, this is odd, then this should be even. Okay, both in a pair, both should not be either even or nor odd. Okay, so here we can see in this example 2 and 6 both are adjacent. Okay, in this pair both are even, so it is not a special. So here it is returning false. So similarly, if we see this example, then here we can see 4 and 3 both are with different parity. 3 and 1 both are odd. So this is not special. Okay. So if this pair exists in any subarray, like here we can see 0 to 2. So 0 1 2. So this is the first subarray. In this subarray it exists 3 and 1, this adjacent pair, so it is returning false for that subarray. And if we check with 2 2 3, so index from 2 and 3, this is subarray. Here 1 is a odd, 6 is a even, so there is no pair such which false. Okay, which makes our subarray as not special. Okay, so this is a special array because there is no such pair exist in this subarray which has a parity, same parity. Okay, now if we solve, how to solve this question, first is a brute force approach. Okay, so in the brute force approach, what we can do is we can just traverse this queries array, 2D array, and then again traverse this num array from 0 to 4. Let's say for the example, let's say this example from 0 to 2, and check the adjacent elements parity, and from 2 to 3 again, and again check. And this will be brute force approach, which will be like more time complexity. Okay, so it may we may get time limit exceeded error also. So next thing is we can solve this question in different ways. So next thing is we can solve using tree map. Let's say what I'm doing is I will traverse this array first, and I will add into the map the pairs which has same parity. Let's say here we have same parity for what, for 2 and 6. So in my map 2 and 6 will be there, 2 as a key, 6 and 6 as a value. So here if we see 3 and 1, I can add it right in the map. So similarly we can add it in the map, the pairs, and then I will check. I will traverse these our queries. Okay, and I will check from 0. Okay, so if we use tree map, then we have ceiling key as a method. You can check. Okay, which will return the least greater number than the value which we pass. So let's say if I pass 0, and we have in our map as 2 and 6. So if I pass 0 and I want ceiling, I'm passing like I want a ceiling key for this 0, then it will return 2. And from this 2 I can get 6, as it is a value. 2 and 6 are key and value. So then I can check with this, it's the end value, that if it is greater than or equal to 6, Okay, then I will what I will write, if it is greater than or equal to 6, that means 6 exist. huh, um, yeah, okay, so the thing is, I missed this point, that we aren't checking the value. Okay, because how it is possible now, this 6 and 4. So in the map we'll be adding the indexes. So we will add 0, 1, 2, 3, 3 and 4. Okay, index 3 and 4, because here we are checking with the index, right? Or else like we can do this thing only key, we will add the index in the map and then we check with this, that if this end value is greater than or equal to this, this will be 4 only, it is not 6, it is the value is the 6, but we will add the index because we want to check at which index that pair exists. Okay, we don't care about the value, we just want that index. For this index pairs, this if this exists in the subarray, then that subarray is not special. Okay, then we can check, and if it exists, then we can say this is not a special, and if it doesn't exist, then we will say this is a special. So we'll mark as a true and false. Okay, so the next thing is, here also again we are storing the pairs and everything, like we are using the map, then ceiling key. It will also like uh, we want to optimize our approach, right? So next thing is, we can do is we can use a prefix concept here, because we have to return false and true, not the like not the exact values, which pairs and all, right? So here what we can do, we can check from starting, like the we know the concept of prefix, right? From starting, look, like prefix sum is what, 3, then 3 plus 4, then 3 plus 4 plus 1, then 3 plus 4 plus 1 plus 2, and so on, right? So similarly we can check in this zero index how many pairs exist. Obviously it will be zero. Okay, from this, again from this two, how many pairs does exist? Zero, because 3 and 4 are with different parity. Now we will check this. Okay, that means 3 4 and 4 1. So 4 1 are with the different parities, again 0. Now with this we have 3 4 4 1 and 1 2, with all are with different parity, with again 0. Then all together 3 4 4 1 1 2 and 2 6. So for this 2 6 pair, both are even. So we will add a count of 1. So let's say we have an array, prefix array. For this example we will see. Okay, now 4 initially 0, 0 pairs. Okay, now 4 3, both are with different parity, then 0. Again we will check with from here. So what we will check first, we know this is with 0, and again now we have to check with 3 and 1. So 0 plus 0 is 0. Now we will check. Okay, wait, it will be 1, right? 0 plus 1, 3 and 1 both are odd, so 1. So this was 0 and this is 1, so 1. Again for this pair, like we are checking from the beginning, and currently we are seeing it for this pair, but we have to what we have to update for from the beginning. So from the beginning, here it will be stored till what, till this index. And if I check with this two, we have to add it to the previous one. So 1 plus 1 plus what, 0, because 1 and 6 are both are with different parity, right? Now we got our prefix array. Now we have queries 0 to 2. So index 0 1 2, how many are present? 1, because we are starting from 0. So we can say directly 1. If we are starting from here, and let's say we have let's consider, we here it will be 0 always. Here we have one pair, and here we have 3, yeah, 3. Okay, because 1 plus 1 is 2, and 3, let's say this. Okay, so from the beginning, if we consider the whole array as a sub array, then we have 3. Okay, 3 pairs exist. But if I consider from this, here if we see, all are either even. Let's say we will consider 4 2 6 8. So 4 2 is even, 2 6 is even, and 6 8 is even. Okay, both are even. So this is our prefix array. So if my sub array is these, then how many pairs are existing? 2 and 6, 6 and 8. That means 2, right? So I will do, end minus start. So end, prefix of end minus prefix of start. So end is 3 minus 1 is 2. Okay, because we have to exclude the first one, this first one, right? So similarly, from here to here, we have only one pair. Okay, so 3 minus 2 is 1. So what we have to check is, if if we are not getting 0, okay, that means it is not a special, because we want different parity. If we have the same parity, then only we are adding it, right? So let's write the code. First, what? Let's say int n is equal to nums dot length, and number of queries is equal to queries dot length, and we have int prefix int n, and we have to return the answer, right? Boolean array. Yeah, the size will be what? Queries nq. Now we have to build the prefix array from, okay, and I is equal to what? I is equal to 1 to I less than n, I plus plus. Okay, here what we have to check, if our num of I minus 1, we are using this because initially I is equal to 0 will be only 0, so we are starting from 1 because pair exists from the position 1, right? If it is, okay, if it is not odd, and current element is also not odd, I mean it is odd, okay, or, so this is one case that both are odd. What will be the another case? Both are even. So both are even. So in that case, what we have to do? Prefix of, so let's say we will initially we will assign prefix of I is equal to prefix of I minus 1, and here we will just increment the current one. Anyway it will be like, so let's say previous we have three existing pairs which are not special, okay, which have different, which have same parity, and current we don't have parity. So in that case also we have to continue what the previous value, that is 3. So that is why we have to assign initially, and then we can increment this. So now we got our prefix array. Now let's traverse what? Our queries array. Now we want our int start. What is start? Is equal to queries of I 0 int end is equal to queries of I 1. Now int let's say you can directly use if our prefix of int minus, so let's say the start, if if it is greater than 0, then we can say prefix of start, else we can return the 0 only, I mean for the subtraction process. And if this is equal to 0, okay, that means there is no such pair exists which have same parity. That means our answer of this I will be true. That means this is a special, else answer of I will be false. And at the end we will return our answer array. So this way we can solve this question. Okay, let's run this. Okay, so there's some spelling mistake. Queries. Yeah, we can say accepted. Let's submit this question. Yeah, our solution got accepted. So this way we can solve this question. You can try with the map as well, even though it will not it is not a optimized one, or um, let's say it's like it will give more time, it will take more time complexity, but still you can try and then try to improve, like go by brute force to optimized one, not directly jump into optimize, because that is why that is the way how you will think. And in the interview also you will you'll use the same approach, so that like this is how the thinking process improves, right? Okay, so thank you for watching this video, and stay updated. Subscribe my channel. If you if this video is helpful to you, please like this video. Thank you so much.